All right, continuing to work towards our application in graph theory 4, we need to define what it means for a graph to be disconnected. Now this definition is an intuitive definition. A more rigorous definition will be given in graph theory 3 of what it means to be connected. Disconnected is not connected. But because we can use adjacency matrices, and disconnected is also a very intuitive concept, I'm going to introduce this concept here in graph theory 2. All right, so let's see, what do you think? Let me draw a graph. And you tell me, or what do you think? Is this graph, now the graph, so this is this whole thing, both pieces is the graph G. Is this graph G, which consists of these two pieces, is this connected or disconnected? That's right, it's disconnected, right? There's no way to get from a vertex of from this subgraph here, G1, oops, not G prime, no derivatives here, from G1 to G2. There's no way to get. So if you start at 1, you can get to 2, right? You can think of it as if you, these are towns and each of the vertices are towns and the edges are roads. You can drive from town 1 to town 2. You can drive from town 1 to town 3. But you can't drive from town 1 to town 4. There's just no roads there. Right? These are islands, or there's a mountain range between G1 and G2. There's just no way to drive from along edges from the vertices of subgraph G1 to subgraph G2. Right, this is disconnected. Now let me draw a connected graph. Let's say 1, 2, 3, 4, 5, 6. Let's say we have something like this, right? Now this is disconnected, right? But if we do something like this, now we're connected. Now there is a way to get from this subgraph, G1, to this subgraph, G2. Right? There is a way. I guess maybe you'd like G1 to be the one on top. That's fine. We can relabel it 1 and 2. Right? There is a way. There is a way, right? You can always drive through this part here, right? That allows you to get from one subgraph to the other. To be connected, you could have lots of different ways to get over there. You could have something like that. Perfectly fine. Lots of different ways. But this over here, this is connected. This is disconnected. Now do you see how if you're disconnected, right, there's just no, disconnected means there's just no way to get from a vertex of G1 to a vertex of G2. All right, let me draw another disconnected graph. Okay, this graph is disconnected. There's no way to get from the vertices of G1 there's no way to get from the vertices of G1 to the vertices of G2 along edges. There's just no way. These are examples of disconnected graphs.